Okay, I know exactly what's happening over here. The function is increasing. So when I go down to the derivative,
Make it positive.
right, must be positive. Now let's take our conversation up a notch here. Not only is the function increasing from left to right, think about what's actually happening. If I'm all the way over here, my tangent line is almost horizontal.
Yeah.
Almost horizontal. So the slope is almost zero. So I should be starting from 0. What happens as I go to the right? My function's increasing. Think about the slopes of those little tangent lines. What are they doing?
Increasing.
They're increasing. So I need positive and increasing. So the graph would look something like that. Yeah.
So you don't take consideration of mathematical?
So actually, I drew this one badly. Positive and increasing as we get closer to -1. So I should not have actually crossed the line -1. Right, what happens is that your derivative also has a vertical tangent line at -1. Because the function is increasing faster as we get to -1. So the derivative becomes more and more and more positive as we get to -1. Now, over here, function increasing again, derivative positive again.
We're going to 0.
But it starts off really positive slope, getting closer to 0. Really positive, getting closer to 0. After 0, decreases, negative slope. So we're going from 0 to like really negative. Over here, function decreasing, starts off almost vertical, becomes almost horizontal. Your graph will be down here at negative infinity, getting closer to 0. That's what the graph of your derivative would look like. This is a rough one.
Is that the graph of 1 over x?
It's not the graph of 1 over x. Great question, but it's not the graph of 1 over x. All right, so let's flip over to the summary part. Okay, the extension piece. If you have time, this would be a really good opportunity to earn a B's point. This is not for a grade. This is just your enjoying the beauty that is mathematics. Yes, enjoying it. Enjoying all the things that I do to your brain. Can I go back to the graph? Yeah. Okay. Something that you all need to know, starting on Friday, we're going to have a short daily quiz every day that you walk in. Short. Breathe. The more of these that we do, the more of them I will drop. From Friday until like forever. Yeah, no. For a while, because it's this last piece over here that I'm incredibly interested in your internalizing and internalizing deeply. So everything that I'm going to put on here is exactly what you're going to see on the quiz Friday. I would love for it to be 100. I don't think anyone's going to get 100 yet. Okay. So we're looking connecting f and f prime. F is increasing, then what do we know about f prime?
Positive.
F prime positive. Let's write it out. F prime positive. If f is decreasing, then
Negative.
f prime is negative. If f has a sharp point,
It's not differential.
then f prime is undefined. Okay? Sharp point is another way of saying cusp point. Just not using my German. Cusp point, right? You have to spit. Okay. If f has a vertical asymptote at x equals a,
It has also.
then f prime also has a vertical asymptote at x equals a. OCO?
Shouldn't it be horizontal axis for the next one? Because it's the as x minus.
Yes. Thank you for being there for me, son. He's not actually my son. I have no son that I know of. Okay. Ha ha ha. Okay, if f has a horizontal asymptote, think about this. As you head out towards positive infinity, you have a horizontal asymptote. What happens with the derivative?
It approaches 0.
If you have a horizontal asymptote, right, the graph starts to flatten out. So f prime approaches 0. So I'm just going to say f prime approaches 0. Okay, let's see how well we can do this. F prime of x is greater than 0. Your derivative is positive, then f is increasing, then f is increasing. Good. If f prime is less than 0, then f is decreasing. Good. If f prime changes from positive to negative, take a moment and actually think about that. If your derivative is changing from positive to negative, what do you know about f? No, wait for some hands. Waiting for hands. I see 3 hands. F prime changes from positive to negative. The function changes from increasing to decreasing, and we would call this, Amanda?
Does it have a relative maximum or minimum? No.
Careful.
A 0.
Okay. F prime changes from positive to negative. So what does F do?
So it was increasing and then decreasing.
Increasing, then decreasing. What would you call that? Melissa?
So I just have to have
A relative max. You blew it because then you said or min. F prime changes from positive to negative. F increases, then decreases. You okay? Sleepy? Okay. So then F has a relative max. Amanda, let's loop back around to you over here. If F prime changes from negative to positive, then F has a relative minimum. Good. Okay? Now everybody can play here. If F has a relative maximum, then F prime
Change from
has a
positive to
root. No.
Oh, absolutely.
Has a 0.
Change
Also
from
no.
Change from positive to negative.
The only thing we know is that F prime changes. I'm going to use the little triangle from positive to negative. And I'll show you why in just a second that this root was wrong. If F has a relative minimum, F prime changes from negative to positive. Melissa. Yes, that's why I'm going to flip it over. Can I flip this over? Okay, bummer. It's all right. Absolute value of x. Does f prime have a root here? No. But f does change from decreasing to increasing here. So if you fall for it and you say root, it's wrong. The only thing you know is this is a relative minimum still. We're good? Okay, finish the problem set. I will see you guys tomorrow.
So what's exactly going to be like on the quiz Friday? It's just going to be over